Hey guys, I'm not here today, so I'm just going to go through your handout with you um, electronically. And there's going to be another video to watch in addition to this one that tells you how to do some skills on the TI Nspire, but you might be able to just watch this video, try the homework. So far in this unit, we've been looking at one variable stats, our shoe sizes, how our height's distributed, point score, test marks. And what we're doing now is we're going to move on to investigating how two different data sets are related. For instance, do you think variables are related in these situations? Smoking and chance of heart attack, relationship between foot size and height, time spent studying versus mark on exam. You probably do think there is some relationship, and a big part of stats is investigating relationships between two data sets. So let's go through some of these fill in the blanks. I don't have my tablet here, so I'm going to be typing. Two variables measured on subjects are correlated. Correlated means that values of one variable tend to occur in connection with values of another. So for instance, high values of smoking correlate with high values of heart attack. When one gets big, the other gets big. That's not the only type of correlation. That is called positive correlation. Okay, when one variable increases, the other one increases, that's called positive correlation. The other type is negative correlation, which is when one gets small, the other gets big, or vice versa. Okay, so what might be an example of negative correlation? Well, for instance, temperature and snowfall could be negatively correlated. When the temperature gets high, you see very little snow. When the temperature gets low, you see more snow. So that is negative correlation. So I'll write that: negative temperature, snowfall. Positive, we did smoking and heart attack. There are many, many, many examples of each. Okay. Now, the variable is all, when you're doing a study, you want to determine are two data sets related. The variable that you change is referred to as the independent variable. I'm sure you know this term from science. Okay, the variable being measured is called the dependent variable. So usually say it was snowfall with temperature. You change the temperature, that would be independent. You can't change the snowfall. And then the snowfall will be the dependent variable. It depends on the temperature. Now we can plot two variable data sets as points on a plane. And in order to make this more clear, I'm going to do a little example with you guys. So on your handout, there's a data set, and it shows the weight in thousands of pounds versus the highway fuel efficiency in miles per gallon for 13 different cars. So I'm going to go over with your GDC how to use that to do a scatter plot here. So I'm just going to start entering it. Oh, can't do that in split view. Okay, so I'm going to just resize my windows quickly. Just give me 1 second. Okay, so you see I have a calculator screen open. Just like one variable stats, I'm going to open the spreadsheet, the lists and spreadsheets. I'm going to enter my data. I'm going to enter my independent variable in one column and my dependent variable in the other. So I'm just going to try and see here. Okay. I'm trying to make any typos. There's one right already. That was more organized. I could have pre-entered these. Oops. You can enter these in your calculator as I do this. If you want to work alongside, I would recommend that highly. 4.02. Okay, now I've entered my weight in that column. Now I'm going to enter my fuel efficiency alongside it. hope I don't make a mistake. It's very easy to make careless errors in the stats portion of the IB because it's all calculated. Okay, there we go. So now I have it, and I'm gonna name each column. Okay, call this X, call this Y. Now I can graph this as a scatter plot. To do so, hit Home, go to Data and Stats, and you'll get this view. You need to click on the x-axis, select which variable you want to be your independent variable. Click on the y-axis, click which variable you want to be the dependent variable. And this is a scatter plot of our data. Now, we suspect highly that this is negatively correlated. As the x number gets bigger, the y number gets smaller. That's negative correlation. Now, we can actually, I'm going to leave this for now. I'm going to go back to our note. We'll come back to the scatter plot. Okay, so we are going to come up with a mathematical description of how strongly correlated data can be. So there's a variable, a statistic called the correlation coefficient, usually denoted by the letter R. And it's given by this really ugly formula. You'll recognize everything in here. The X with the bar over it is the average of the independent variable. The Y with the bar over it is the average of the dependent variable. N is the number of data points you have. Sx is the sample standard deviation for X. And Sy is the sample standard deviation for Y. Luckily, we don't have to do that by hand in our course. We can calculate this number on our TI Nspire. So let's do that. The easiest way to do this is to go back to our spreadsheet. We're going to click on an empty cell. We're going to go Menu, Statistics, StatCalc, two variables. Now we have two variable stats. We have two variables. We have fuel efficiency and weight. Our X list is in A, but we can select X because we've named it. Otherwise, you could put A. Our Y list is in column Y, but we could also just put this. And we're going to hit OK. And we get a bunch of two variable stats. It gives you all the one variable stats for each variable. You see the standard deviation of the X, for instance. Same with the Y. But what we are looking for is the correlation coefficient. This tells us our correlation coefficient is negative 0.8977. So it's negatively correlated. And what does that number mean, 8977? Well, a few things you should know about the correlation coefficient. Values of R always fall between -1 to 1. 1 is a perfect positive correlation. All of the data on the x-axis perfectly predicts the data on the y-axis. Negative R values mean negative correlation. Outliers can be distorted. When I come back in person, we'll have a little more conversation about the correlation coefficient. But now you know how to calculate them. We're going to call two variables strongly correlated if R in absolute value is bigger than 0.7 and weakly correlated if it's less than 0.5. And I have some really interesting examples for correlation we'll look at when I get back. But this should be enough to let you do the homework. Okay, the homework is the scatter plots and correlation worksheet. I want you to try that. Thanks.